Okay. We are going to learn time series model today. Okay. I request you to shut down your computer, please. The time series model we are going to learn. Maybe today we are going to learn only one. This is called moving average model. Where is the pen? So next 2 or 3 classes, we are going to learn 3 time series model. Time series model. So what are these? Today we are going to discuss moving average. It is written as MA and then Q. Q means order of the error term, moving average. And then second one is autoregressive model. And third is ARMA. It is MA, this is AR, P or Q, something like this. And ARMA, autoregressive. Moving average. It is written as P and Q. So these are the models we are going to discuss. Okay. So there are other models. Those are known as the ARIMA model, ARCH, autoregressive conditional heteroscedasticity, GARCH, generalized autoregressive conditional heteroscedasticity. These are also other model in order to handle stochastic volatility. Okay. So Moderna developed vaccine, right? Moderna developed vaccine, right? When it comes to the market, and then their stock went up, right? Stock is going like that way, suddenly bump, right? This is called stochastic volatility. Okay, so those are the things could be handled by ARIMA, ARCH, GARCH type, but this is for your final project. I'm not going to take any final exam, but this final exam I will grade very seriously. Letter by letter I will read. Okay, each line of code I will read. Are you understanding? So maybe tonight I am going to upload the last homework. The last homework is coming from these 3 topics, and this is for the final project. Okay. Okay. This is for the final project. Maybe I will upload today. And final project, when you will do, read the instruction. Okay. It is called, in the context of our society, the person is doing very good, but at the end, when he about to reach in the shore, he sank his boat. Are you understanding? His boat is sunk, right? He is doing very good, all the way doing very good at the end. So be careful about your academic integrity. And you already noticed that how carefully I grade. And a lot of homeworks you already submitted, right? 2 more homeworks to grade. One is for non-parametric regressions, another one is for linear mixed effect model and quantum regressions. These 2 homework I will grade, this homework I will grade, and this final project. So that means 4 things I will grade. Clear, right? So don't take lightly anything. And strictly maintain academic integrity. strictly maintained. Okay, so now moving average. Let me just writing something visually so that you can understand what is moving average is. Okay. So this is the day 1. This is a day 2. This is a day 3, day 4, and it will go all the way up to in there. Okay. And this is the car sales. Okay. A car dealer want to sell the car. So in this case, suppose he sell, this is 2, 5, and then suppose this is 10. So suppose he sell here 2 car in here. Okay. 2 car is sold in here, and then day 2 they sell suppose 7 car in there. Okay. So what is the average now? Average is in between these two. This is the average, right? This is the average, right? This is the average point, right? This is the average. So this is the average. So now in day 3 they sell again 6 car, suppose, right? Now average change, right? 3 data point, now average change, right? Now day 4 they again come in here. Now again average change, right? Now average could be like this. This could be the average. So this could be average, means this is the average value. This is the average value. Previously first point, that point, and average is the same. When it is the second one is adding, averaging these two could be something like this. And then third one is, so this is the idea of moving average. Okay, so that means you are going like this way, that way, and like this way, this, that, this. On an average, you are getting an average in there. Suppose average is equal to 5. Clear, right? So now I am going to write the model. First of all, today I am going to give you a real life example so that you can visualize these things, and then I will do the all mathematical derivations. They are mean, variance, covariance, correlation structure, different orders of the moving average model. Okay, different order of the moving average model. So I want to ask you a question. This is a simple linear regression model, beta 0 plus beta 1 x1, or just I want to put xi plus ei. Here ei is the error, right? Ei is the error. We can have error only if we have a error is estimated yi minus yi hat, right? This is the definition of the error, like how to. So we do not know the error, but error can be estimated, which is known as the residue. Estimated error is also known as the residue. Okay, estimated error is known as the residue, right? So this is what we can do. So now my question is, estimated error means what? This means what? I have beta 0 hat, beta 1 hat, xi. Suppose I want to put here yi hat equal to 3 plus 5 xi. Okay, 3 plus 5 xi. So originally y equal to suppose 7. Original y equal to 7. y1 equal to 7, original yi equal to 7. That there is a rationale why I am discussing these things. So suppose original y1, first one equal to 7. Now suppose I want to plug corresponding to y1, my x1 is suppose 1.5. Okay, so now I want to put there 1.5, 3 plus 5, 1.5. So then what we are getting in here, 3 plus 7.5, right? So that means 10.5, right? Right? So now what is my EI hat? For the first observations, my EI hat equal to 7 minus 10.5, which is equal to 3.5. This is the estimated error, right? Are you understanding? I say suppose beta 0 equal to 3, beta 1 equal to 5. If this is the scenario, then my estimated error equal to this. Are you understanding? So residual means what? Residual means estimated error, right? Residuals means estimated error. Is there any other way? Is there any other way to compute estimated error? Or residual? Do you understand my question? Suppose this is your question, someone asks you. Well, so you feed the model, you use the data, and then you will make a point-wise prediction. After point-wise predictions, now you have a predicted value and original y value. Original y value and predicted value, you take the difference, you get the estimated error. Is there any other way you can estimate? Okay, estimated error. Do you understand my question? I want to estimate this culprit, this criminal, any other way. Okay, so other way is this. yi I have already in my hand, right? yi already I have. We fit a regression line like this way, right? And this is called average, right? For average regression line. So other approach, if you do not, someone asks me other approach, you said that I will just subtract the average. So yi equal to what? Yi equal to 7, and then average equal to suppose your 8. So and then again this is y1 minus this, y2 minus, you can put here y bar, y2 equal to suppose 8, 8 minus 8 equal to 0, here equal to minus 1. This is the another approach. You understand, right? I am, because the y I have, I want to subtract the average from each data point. That could be an alternative for error, because regression does what? They fit a average regression line. Okay, after doing this, now I am going to write this is the book, very fantastic applied book, lot of examples is in there. In my handout that I don't know whether I have uploaded the handout, I have given the descriptions, the how to use this book. Okay, so now let me start moving average models. So what does the moving average did? So MA model predicts future values. MA model predict future values of a time series of a time series using past error. Using past errors. When I will give you a small scale example of the car sales, then you will understand how they using past error. So their model has a formula, general formula. That general formula is written. Did I write today? Did I write in the last page? Okay. Okay. So moving average model is this: YT equal to mu plus this one plus current error. Epsilon is the error, current error. This is the past error, epsilon t minus 1. And this is a parameter which should be given. So this is the way moving average model is written with, this is known as the only one error, like lag, only one error lag is taken. This is the current one, this is the only one, like only previously one. So this is denoted by, this is written as a moving average of 1. It is a notation 1. Why they write here? This is the current one. This, in this case, we are predicting future value of this series based on the past values of the error terms. Past values of this is the current one based on the past values. Now, what is mu and what is psi 1? So these are the values. Mu is the average, like starting from where you have started, like average, like when you at the end you will find the average, that average is the mu. Okay. So after writing this, let me immediately go to a problem. After that problem, then I will start deriving all of the mathematics that lies behind them. So come in here, you understand this, right? So MA model predicts future values of a time series using past errors, and this is the way the mathematical model is written. Take a look at that. This is the YT. I am predicting the YT. I am predicting the series. So someone who have a good expertise on dictation model, they immediately ask a question. How can you predict YT from the error which we do not know? Do you understand? So that is why first few minutes I spent how to estimate error. You understand, right? First few minutes, why did I spend some time for estimating error? Because in order to convince you, there is a way to estimate the error. Okay? One approach I have shown you from subtracting predicted value from the observed value. Another one, subtracting average from each value. Right? That is the way you can get the error. So a person who have a lot of predictive modeling experiences, if he will see this, immediately first question will come to his head: how can we express dependent variable series YT in terms of the past error? Because error we cannot get any value, error need to estimate. How can we estimate? By fitting the model. But before fitting the model, how can they do this? So the answer is alternative approach of estimating this mu, this epsilon t minus 1 is this one. Is this one that I mentioned. Okay. Now, slowly, I am going to show you how to do these things. So far, so good, you are understanding? Okay. Now, let me write these things in here. If I write these things, car sale example, car sales example. So car sales example, I want to put here day I want to write here day. Then I want to write here prediction. I want to write here actual value. Actual value. And then I want to write here error. I want to write here error. And then day 1, day 2, day 3, day 4. Okay. So suppose first day the dealer sell so first day the dealer sell suppose 4 car. Okay. And that is the opening day of selling the car. They do not have any prediction in there, right? So that means error is also nothing, right? Error is also nothing. Here, as there is a 4, we can consider our mean equal to 4. Are you getting it? Because first day, right? So we can consider mean equal to 4, which is equal to our mu. Now we have to assume our this parameter. Suppose 0.5 I consider this. Okay. So the model, that was the model, right? I want to consider this is equal to 0.5. Let's see how it will work. And then day 2, we are predicting, that I can sell 4 car because of previous 4 car, right? First day, 4 car is sale. Day 2, before going to the shop, I am predicting that we can sell around 4 car. Okay. But actual value come here as a 10. Understand? Actual value come here as a 10. So now error is what? -6. -6, right? Actual one is -6. Now I want to predict that one, the third day one. Originally it was 4, right? Plus my that parameter equal to -0.5, right? And times my error equal to what? -6, right? I'm just plugging this one. Then what did I get? I get here 7. Third day, before opening the shop, I predicted from my model 7. At the end of the day, I found that I actually sold 14 car. I have no control on it. If customer buy more car, what can I do? Do you understand? This line, I do not have any control. This line, I do not have any control. So now, what is the error? -7, right? Are you getting it? Are you getting it? So, and then 4th day, what we can do, my starting is 4, right? And then again, I put like this times 7, right? Which will give me 7.5. Then 7.5, original sale is 9. So I have what? -1.5, right? So that is the way time series model with average, moving average model got constructed. Now I want to draw a plotting for that. Okay, let me spend one more time in here. That would be most important for your life. Down the road, because when I was reading this model, first time when I see that response variable y is modeled with the past error term, I said immediately, error term, error beyond human control. From the regression, what we learned, error beyond human control, right? Error term, how can we get that? That is the first question came to my mind when I was doing these things. But that is why at the beginning of the class, I explained to you how many ways we can estimate the error. And this model was proposed in 1928 by Slarsky. Okay? It is not 100 years old even. The subsequent model that you will get, autoregressive model, ARMA, those are even not 15 years, not 50, 60 years. So statistics is compared to like mathematics, physics, or chemistry. Those are 500, 600, 1000 years old. But statistics is even still even not 100 years old. Many model developed just last 50, 60 years. Now I can draw this as I mentioned to you earlier. So this is the figure I can draw here. 1, 2, 3, 4, 5, 6, 7. So this is day 1, day 2, day 3, day 4, and day 5. That's enough. So suppose this is equal to 5, this is equal to 10, equal to 15, 20. This is equal to. So day 1. Now I want to construct two, one for the actual, another one for the prediction. Okay? Okay. So actual one, it started with the 4. Let me do the 4 one. And then it go to the 10. Here is the 10. And then it is go up further to 14. Day 3, it is 14. 14 and then 9, right? So 9 is in here. So my solid line is this. Okay. Now, if I take only these 2 points, my average could be something like in here, right? If I take these 3 points, my average could be something like in here. If I take all of these 3 points, the average could be in here. Average could be in there, something like this. So this is my observed. That means this is called the actual time series curve. Now I want to do the predicted one. Predicted one, first one, there is nothing, right? Second one, day second is 4, which is equal to this. And day 3 equal to 7. So 7 will go in there. And day 4, it is 7.5, which could be in here, right? So that means like this. Right? So that is there is nothing, 4, like this. So if I want to write MA2, then what will happen? The MA model predict future values of a time series using past error. In such a cases, MA2 will be, let me write it in here. MA2 will be Y2, YT, mu plus psi 1, epsilon T minus 1, psi 2, epsilon T minus 2, and then current one. That is the way you can do it. Okay. This is the MA2 moving average. Now let me start deriving things. We will start what is a general linear process. What is general linear process? So this book has a lot of example, and if you are interested down the road, if your research would be on the time series, if you are interested, so write this book name, time series analysis with application in R. Who are the author of the book? Two persons write this book. Jonathan D. Cryer and so these two persons write this book. So now I want to do what is general linear process, and there are mathematical derivations now. They are covariance structure, and then whether there is a stationarity problem or not, non-stationary. So let me explain what is non-stationary. Any expression that I'm going to show you, variance, covariance, on those expression, if the term t appears, then it is non-stationary. What does that mean? T value go up, its shape go up. T value go down, its shape go down. On the other hand, if t does not exist, even though the variable itself has t, but the final expression does not have a t, so that means that is stationary. Understand, right? So suppose in expressions there is a letter t. T stands for the time. For the variance, covariance, t does not exist. So that means that is a stationary. If t is in there, then that is called the non-stationary. So a general linear process. Okay, and another things. What is the difference between random variable and stochastic variable? Random variable and stochastic variable. So stochastic variable or process, birth process, death process, they always have a time variable, time. Both of them are random, but in stochastic variable, in addition to random variables property, it also has a time variable, process, birth process, death process, renewal process. Okay, we buy the insurance, right? We have to renew the insurance, right? That follow a mathematical model, renewal process. So the difference between random variable and stochastic variable or process such as birth process, death process, renewal process, and there are some other processes that involve another characteristics known as the time. Time must be in there. Understand, right? So now I want to discuss what is general linear process. A general linear process is one is one that can be represented as a weighted linear combination, as a weighted linear combination of present and past white noise term. Present and past white noise term. This is also known as the errors. Many people write like that way. They said white noise. White noise means just the error term. Okay. And it has a mean equal to 0. Mean equal to 0. And it has a variance equal to sigma square. So a general linear process is one that can be represented as a weighted linear combination of present and past white noise terms. White noise terms means error. Okay, white noise terms. So it can be represented at a general linear process denoted by YT. So denoted by YT, it could be presented at YT equal to this plus, I am writing sometimes epsilon, sometimes I am writing E. Psi 1 E it will go. Can it be an infinite series? What will be the problem if this will be infinite series? And suppose it is not infinite series, then how can I handle that? What is the problem? Is this an infinite series? Infinite series means it will explode, right? How can I control that? If it will explode, then I have to put, if I put here something, some type of function is there that is decreasing, then that explosions could be controlled, right? Are you understanding my point? If any number between 0 and 1, if you square it, then it will go down further, right? And if you take the cubic or like to the power 4, 5, 6, it will go down. So if you think that this is the infinite series, that will explode, no. Because we can control how the values of psi 1, psi 2, psi 3 behave. So if the right hand side of this expression is truly an infinite series, if the right hand side of these expressions is truly an infinite series, then certain condition must be placed on psi t. Then certain condition on psi or maybe psi t, something like that, must be placed on psi's weight for the right hand side to be meaningful mathematically. Must be placed on psi weights. I will give you an example. Psi weights for the right hand side for the right hand side to be meaningful mathematically. What does this mean? I have written a process. The process always involves the variable time. Time should be there. This is a process. Okay. Now, after writing the process, somebody said that, well, this is an infinite series and it will explode. What beneficial is that, which is in infinity? Then the counter argument that we will put certain restrictions on the psi i's so that if error terms is either fluctuating between certain numbers, then it will go up, but I can scale down those successive error term for the past years by new values of psi 1. So what is one of the meaningful? So for our process, it suffices to assume that these psi I square sums must be less equal to infinity and psi 0 equal to 1. Psi 0 equal to 1 is actually adding in here, psi 0. Okay, it is actually in there, psi 0 equal to 1. So that is the condition psi. Now, I want to give an example. What could be the psi? So we can consider, suppose psi j equal to phi j. Understand now? Where phi j must be less than 1. Okay? You understand the definition of this, right? Absolute x greater equal to 1 and absolute x less equal to 1. You understand this, right? So this is equal to what? If this is equal to 0, absolute x greater equal to 1. This is 1, this is negative 1. So this meaning that part, this meaning this part. Okay? And this is equal to this one. This is equal to this one. Okay? Why I explain this? So that means phi takes value 1 to negative 1. That's the reason I said that absolute phi equal to this. So this is negative 1 to positive 1. So that means this is a decimal negative number or decimal positive number, right? This is equal to decimal positive number or decimal negative number. As I said equal to power, as the series goes up, then this quantity will go down. Okay, this quantity will go down. Another approach you can put here also, psi j equal to e to the power minus j. Okay, e to the power minus j, that should always be less than 1. Okay, this is the one approach you can put like this way. Another approach you can put like this way, but mathematically this one easy to express. So that is a mathematical derivations could be given like that way. Okay, are you understanding? Okay, let me again refresh your head. Are you seeing these things? Is going up to infinity, right? And there is a high chance of explosion. if the weight psi I are greater than 1. Because the error terms, the way we computed, if that way error term is computed, sometimes on positive, number, either it will explode to negative or it will explode to positive. One of the two things will happen. How can we control that? We have to introduce weights this size in such a way that that will lie between -1 to +1. So that means negative decimal number or positive decimal number. One is this approach, another one is that approach. Okay? And then this phi takes value, any value. Suppose phi could be 0.3. Okay? Psi could be 0.3. Okay. So after that, now let us do some of these computations. And we have to find some of these things. From here, you might need to work for a problem that will involve e to the power g. Okay, the computations that I'm showing, that is involved with this equal to that one, but in your case, this is not y, this is psi. Your one would be this. How the computations looks like if you use these things. Okay, but I will decide. So what will be the main problem? After finding these things, then I will decide whether I can ask you these things. Okay, suppose I want to take now yt equal to take a look at that. Previously it was psi 0, which is always equal to 1, psi 1 and psi 2. So psi 1 I put this, psi 1 I put this phi, and that one I put phi square. Okay, so just that. So that general linear process become this. Okay, now I want to find the mean of this. Expected value of yt equal to 0 plus 0 plus 0. Why? Because expected value of epsilon t minus 1, this is equal to 0. White noise, this is called the error or white noise. White noise, which has a mean 0, mean equal to 0, and variance equal to sigma square E. Okay, these are given. Okay, now I want to find the variance of yt equal to variance of et psi. Let me write here in the format of et, so then it is easier as I have written. Let me write it always in the format of et plus. Okay, so now variance of this again, these things, like if you want to find the covariance of these things, that will be 0. Error terms are independent, successive error terms. That is the covariance equal to 0. So now there is a sigma square E. Just I want to put sigma square. And then here is a 1. Here is a pi square. And there is a pi square 4. Something like this, it will go. Do you understand these things? How did I write this? Okay. Variance of x plus y could be written as variance of x plus variance of y plus 2 covariance of x comma y, right? You know this, right? Right? This is the variance covariance formula. But here I cannot write any covariance because expected value of ET and ET minus 1 is always 0. Covariance of successive error terms are 0. Are you understanding? So that's the rationale I have written like this way. Now, how can I do that? What is the condition for psi? What is the condition for psi? The psi's condition is what? It must be like this, right? That is the condition, right? Here I write the condition. Here I write the condition. So this psi, someone take independently, she has to take 0.9. If this gentleman take, he has to take negative 0.7. That is the condition I have given you, right? Now, take a look. If this is equal to, suppose this is equal to 0.7, sigma square 1 plus 0.7 square, 0.7 to the power 4, then 0.7 to the power, if I take here 3, then square equal to, it will be 6, right? 6. X. Now my question is, how can I compute these things? Is there any formula? Are you understanding what I want to say? That must be a finite number, right? Because this is diminishing. At certain states, it will be 0. It will not increase, right? Are you understanding? It will be diminishing. Is there any analytical solution for that or numerical solution? Is there any analytical solution or numerical solution? Numerical? Analytical solution? How do you know? It's a series? Okay. It's a series. There is the analytical solution for that. Didn't I tell in your class that when you go up and up, upper level study like MIT and Stanford, or top scientists, they give a speech, they say one thing during their speech. For certain reason, for some mysterious reason, there is some formula to come. Do you understand what I said? So I listen it from them. That either we yet to discover that thing or it is already discovered. That is their question. You understand what I said? So there is a certain formula that is already discovered or yet to be discovered, but there is a certain formula. So I was reading how mathematics come into an existence, all of this limit, continuity, differentiability, and they're fantastic. People are independently working in Germany, in Russia, in France, and England. So, like medieval is 2000 years ago, when the number system was not developed, the shepherd who take controls of the sheep in the morning, when he take the sheep from his farm, there is a bunch of stick. So one sheep go out, he take the stick and put it in here. Okay, all the sticks put in there. That means that many sheep. And at the late afternoon, evening, when he returned back, because counting system was not developed, okay, then he again matches whether the sheep, the actual number of sheep was there. This was very fun in history when I read that book. So outside of your like knowledge, also read some history that will enrich your knowledge. Now I want to show you how this is a finite series. There is an analytical solution exists. Understand, right? So take a look at that, how I am solving these things. So come in here, I will solve in here. Our series was S equal to 1 plus 5 plus 5 or 5 square. It starts from 5 square, I guess. 1 plus 5 square, okay. 1 plus 5 square plus, this is 5 to the power 6, something like this. It will go. Right? So now if I multiply here by 5s, then what I am getting? I am getting in here 5 and then 5 cube and then 5 and then like this. Okay. Okay. If I multiply it by 5 square, then it will be 5 square, 5 to the power 4, 5 to the power 6, right? Both sides I multiplied by the 5 square, right? Now I want to subtract 2 from 1. 1 subtract 2, then what I am getting? S minus 5 square S equal to 1. Do you agree with that or not? Do you agree with that or not? Agree with that, right? So now if you take the common of S, 1 minus 5 square, right? Equal to 1, right? Then if you put here S equal to 1 over 1 minus 5 square, right? Samida, you look.
5 square S minus.
I put here S minus, okay. Between these two terms, which one is bigger?
S.
S is bigger because 5 square is decimal number. Okay, that was your confusion. So now this is the result, right? Right? So now if phi equal to 0.3, then your result is 1 minus 0.3 square to the power 1, right? So that means 0.91 like this, right? So that means 1 over 0.9. That is the value of the S. And S equal to what? This. This is only possible. This is only possible under the condition that this condition satisfied. If it is greater than 1, then destroy it. You destroyed everything. Okay? Exponentially faster, polynomially slower. So it is if greater than 1, then you cannot solve this. So we have proved from there, variance of yt equal to sigma square 1 plus phi square 4 phi square phi 6. All of this is coming into sigma square 1 minus phi square. Okay. So what do we get about mean? And so mean, that means expected value of yt equal to 0. And this is the mean and variance of the series yt that has 2 error terms. Okay. That has 2 error terms. Now we want to find the covariance. So in order to find the covariance, I have to find the covariance for the series yt and yt minus 1. Yt and yt minus 1. So let us write like this way. So now I take instead of a specific 2-term series, now I take this is 1, another one is e to the power t minus 1 plus phi t minus 2 plus pi square t minus 3, like this. So this is a comma. This is for the series of that. This represents the series yt. First one represents series yt, second one represents series yt minus 1. Now in here, it is a covariance of, I can take like this, t minus 1. So these and that will come together. Okay. Plus covariance of this and that will come together. Rest of the term will not be considered. Rest of the term will not be considered because here we have a matching. So that means we can consider that as a variance. And covariance is always 0 because successive terms are not correlated. So if we want to find it in here, we get here phi sigma square plus phi square sigma square, and then phi square sigma square, then phi cube, phi cube sigma square it will go like that. So now if we take common sigma square and phi, then we have in here 1 plus phi square 4 power 6, all of this, which you already find. So now we have in here phi sigma square 1 minus phi square. That is this over that sigma square. Are you getting it? So the purpose is you are asking me, Professor, you wrote some model and then you give an example. Now you are trying to derive some variance, covariance. What is the rationale for that? This could be a question, right? Are you understanding? This could be the logical questions, the why you are finding variance, covariance, correlation. Because on those terms, I want to see whether the T exists or not. Do you understand? If T does not exist, so that means this is stationary. So, usual question is come to your mind. Previous sandwich classes, I count and derive all the mathematical model, give real life example, never derived any like variance, covariance thing. Why we are doing that? Because if your model is non-stationary, then it is difficult to predict. If T value is in there, in the model T value is in there, it can go, it can take any shape, right? People always want stability, right? But not all time, they want change in their life, but stationarity for mathematical modeling is important. So far, this is the covariance term. Okay, this is the covariance term, and that is the variance term. Okay, variance term. That is the variance term. Previously, it was covariance term. Now we want to find the correlation. Correlation of yt and yt minus 1. So covariance can be obtained by what? Covariance could be obtained like covariance of yt minus 1 divided by variance of yt and variance of yt minus 1, and this is the correlation coefficients formula. So you can put here sigma square, and then here you can put here 1 over phi square sigma square. This and that cancel, so we have okay. So now this and that cancelled out, this and that cancelled out, right? So we have just the phi. Do you agree or not? Do you agree or not? Does it involve any T? No T is in there, right? So now I want to replace this T by K and see the formula, how the correlation formula look like. Yt, the formula changes to this. Rest of the term are the same. Because of what? Covariance, we will obtain these things. Covariance, we will obtain these things because which you can obtain easily by finding the covariance of this, covariance of yt minus k could be obtained like this. Okay. It is important to note that the process defined in this way is stationary. Okay. So just let me, I don't want to write in a book format, but I want to write in a very naive format. Naive format. Since expression of covariance and correlation and variance does not contain any time parameter, so the process is stationary. Stationary, stability is in there. You understand what is stationary, right? Stationary means the time parameter t is not in there. If t is in there, for different values of t, it will show different kinds of behavior. Okay. The auto covariance structure depends only on the time lag. Auto covariance structure depends only on the time lag. This is a lag, right? T and t minus k. This is the lag. How many lag? K lags. That means I am lagging behind you. How many steps? 5 steps. 5 steps I am lagging behind. So autocorrelation and autocovariance function does not depend on the time parameter. Instead, it depends on the number of legs. So this is yt and yt minus k. What is the difference? Both of them are the series. One series is k step away, k legs away from the other leg. Okay, so that is why I write here the autocovariance structure depends only on the time lag, not on the absolute time. Time lag, not on the absolute time. So I have 3 more pages to finish. So you can take a 5 minutes break. Let me drink some water. Let me wait 2 more minutes. I will start 7:25. So for a general linear process, for a general linear process that is written as before, if it will go like this way, then mean equal to always 0 because white error or white noise or error term has a mean 0 and its covariance function known as this could be expressed like this. I will quickly derive these things. I plus k and I takes value 0 to infinity for k greater equal to 0. How can we obtain these things? Again, see, when I find the covariance for the general entire linear process. After linear process, then we will define general formula for the moving average, and then we will find their respective covariance and variance and correlation structure. Yes. Which one? Here? So take a look at in here. Are you seeing here? T is the time, right? And this is the lag. How many steps I am behind? Okay. So between these two, this is forward, this is backward, right? So he is 5 steps ahead of me. So that means this is t minus 5 and this is yt, right? So when I find this formula and final expression does not involve t, but it involves k. Understand? And leg is fixed, leg 4, leg 5, lagging behind. That is fixed, that cannot vary. But if instead of k, if there is t, then t varies, right? Then shape of the variance covariance structure will vary. In that case, it will be non-stationary. And it is difficult to model non-stationary data. There is a process, how to handle the non-stationary thing. They make some transformation, some differences in order to make it stable. And then there is a test of hypothesis to check stationarity, non-stationarity. After doing these things, then they go for the modeling. But you understand what is the time and lag, right? So now I want to show you how to compute these things. That could be obtained if I write covariance of yt and yt minus k could be written as covariance of et psi 1 et minus 1 psi 2 et minus 2 plus psi 3 e t minus 3, at it will go, and then it will start e to the power, sorry, e t minus k plus psi 1 e t minus k minus 1, and then it will go t minus k minus 2. It will go like this. And when these terms are multiplied, then we will see this type of thing. T minus k, k plus 1, e to the power, t minus k minus 1. The purpose is having a multiplication in this way so that I will get a common term in both areas. I will get common term like e square. So in that case, it will become variance. In non-matching case, it will be covariance, it will become 0. So and then final term, if I want to write one more time, that one could be k plus 2 and t minus k minus 2. It will go all the way like this. And then finally, sigma square that's the rationale, because this part will be variance, this is variance, which is equal to that, and this rest of the things are the coefficient. Rest of the things are just the coefficients, I plus k. If I plug I equal to 0, so then that means I will get this will become 1, this will be k. So that's the way it has been derived for the general linear process. General linear process. Okay, so now I will write the general moving average formula, which could be written as general moving average formula could be written as yt equal to et minus theta 1 et minus 1. Previously I wrote there positive, but it could also be written as a negative. T minus q. You remember I started this model. This one has been written in this format. In this format, this one could be written. Now I am going to write a sentence. That sentence could only be understood if someone try to understand the example that I gave. So the terminology the terminology Nology moving average arises from the fact that YT obtained by applying the weights 1 negative theta 1 negative theta 2 and it will go negative theta k, this is theta k, to the values ET T1 T minus Q and then moving the weights and applying them to obtain y t plus 1 and so on. Believe me, if someone just read the theory and then read this sentence, they will not understand what is the meaning in here. You remember when I draw the table and I move one after another, right? So that's the way it is mentioned in here. The terminology moving average arises from the fact that YT obtained by applying the weights these to the values that are because arrow term that we made and then multiply this with this arrow term to get a new value, right? So that's the rationale, and then moving the weights and applying them to this. Believe me, when I read these things and writing these things, I say, no, I don't understand these sentences. When I first read these things, I said, no, I don't understand this. I have to understand these things in different format. Believe me, without understanding this, what we have done in here, in this table and figure, they are actually doing the same thing in there. That is the sentence. Okay. After doing that, now we will do some first order average processes. We will find from this model. So our model is now first order model is YT equal to ET minus theta E T minus 1. Okay. This is our model. So in this case, we want to find the mean expected value of YT equal to 0 and then variance of YT equal to, this is sigma square, and then that one is theta square, sigma square. So we have sigma square 1 plus theta square. This is that. Now see, previously I wrote a one type of equations. Now I write the same equations, but it's little bit of different format. Here I did not use just the intercept term. Okay. What did I write? First, when I give you the example, I write like this way, mu, and then this one, epsilon t minus 1, and then current T1. So these two part is these two part. I just did not include that one in this model without intercept, without average. Okay. So down the road, don't need to be confused about the model that I write at the very beginning with this one. Okay, don't need to be confused. Same model. So now I already find the mean and variance of this one, and now want to find the covariance of yt and yt minus 1, which is covariance of et and theta this. Okay, this is the two model. This is what the first series. This is what the second series. These two series has only difference is that one series is one leg away from the other. Okay, so now if we want to find the covariance of these, there is only one matching term, this with that one. Rest of the term there is no matching, so we can write here covariance of just t minus 1. So we can write here theta sigma square. What I did in here, you know these things, right? Covariance of x comma y equal to expected value of x y time expected value of x and expected value of y. This is the covariance formula, right? Right? So I apply covariance formula exactly same in there. So joint expectations. So individual expectation will be 0 if there is a error term, and then this term will become square term. These terms become square term. These terms become 0. So that means it will come down in here. So that is equal to our covariances. After covariances, this term now, similarly, if I want to find the covariance between another two terms, yt and yt minus 2. Take a look what I am doing in here. This is the leg 2, right? Second leg. So this is the second leg. If I write this formula in here, covariance of et theta et minus 1, and then I write here et minus 2 minus theta et minus 3. Okay, is there any common term? No common term, right? So it will be is there any common term? No, so that means 0, right? It is 0. So in summary, for moving average one model, what do we get? We get, this is our model yt equal to et minus theta et minus 1, expected value of yt equal to 0. This is equal to variance of yt equal to sigma square 1 plus theta square, and then rho, that means correlation coefficient, equal to, here is a covariance and there is a variance, variance of yt minus 1, variance of yt, variance of yt minus 1, and then we are getting in there these values, sigma square 1 over theta square. So that is sigma square 1 plus theta square, sigma square 1 plus theta square, and the covariance is minus theta sigma square, minus theta sigma square. So we are getting in here minus theta over 1 plus theta square. Okay. And for other term, covariance and correlation equal to 0 for k greater equal to 2. Okay, which I just showed you before. So in the time series, all time series model is also a process. Why? Because the variable is collected with a value associated time. Okay, so that is why I discuss you what is random variable and what is stochastic variable or process. So I have shown that there is only one leg I can find variance, covariance, and correlation coefficients. Now second order term, and then finally the general term I will write their structure, and after that we will stop in there. Tonight I am going to upload your homework. That homework, one problem from moving average, one problem from autoregressive model, and then another one for autoregressive moving average. So next 2-3 days I am going to discuss these things, and then another project I will give you, which I will not discuss. Project part I will not discuss. I have elaborated things. You will read the material, you will find the data, and you will write a report. Okay, I'm going to give you again. Throughout the semester I did not say anything, but be careful when you submit your final project. Okay, be careful. Academic integrity you must maintain very strictly, and that will determine also your grade. I want a very good report, and I will elaborate those things in the instruction. Okay, second order moving average model, known as moving average 2. So in the second order, I have to write it yt equal to et theta 1 this is the model. As usual, as each term has an arrow term, so mean should always be equal to 0. Now variance could be now sigma square 1 plus theta 1 square plus theta 2 square. Okay, covariance term will be 0. Covariance terms will be 0. Now I want to find the covariance of two series with one lag apart from the two series. First series is y2, second series is yt minus 1. First series is yt, second series is yt minus 1. So let me plug the value of the series as et minus theta 1 et minus 1 minus theta 2 e t minus 2. Then that one is et minus 1 theta 1 e t minus 2 theta 2 e t minus 3. Okay, so we have to find the term that are matching. So we see a matching term of covariance of this one matching with that theta e to the t minus 1 e t minus 1. This one is 1 and that one is another one. Okay, so that one is another one, covariance minus theta 2 minus 2 and minus theta 1 e t2. So the arrow terms or white noise that has similar legs are put together, because this will generate my variances. So this will generate my variances, and there is a comma between them. Okay. So from there we can compute now. From here I can find here theta, and from there I can find theta 1 and theta 2. These two things I can find, and then finally I got the sigma square. So final result is theta 1, theta 2. This is a theta 1, right? Yeah, this is a theta 1 sigma square. And it must be a negative sign. It must be a negative sign. Must be a negative sign. Now we want to find covariance of two leg apart. So here is a one leg. Yt and yt minus 1 are away from one leg. Okay. Or one time leg. So maybe if I put just the leg, it will be confusing, one time leg. So in this case, it will be two leg, and we want to see how the covariance formula look like, where the models are moving average model. Covariance of ET it is just the expansion of the series. If yt looks like that way, yt minus 2 looks like this way. So now we will again combine this and find the general expression. So general expressions would be covariance of, I think there is only one match. There is only one match, which is yt minus 2 and this one. So we can write here minus theta 2 e to the power e to e t2 and e t minus 2. That is what. So we have theta 2 sigma square. That is the results. We want to find now correlation. Let us check correlation. Let us check correlation. So for the M2 process, if I want to find the correlation like this, these two, so that one has a notation as gamma 0, that is a variance. So we have expression minus t theta 1 and theta 2 divided by 1 plus theta 1 square and theta 2 square. And this is the second one, where we have the value 1 plus theta 1 square and theta 2 square. For second order moving average model, or the moving average model that has a second leg, in such a cases, this will be 0 when leg is 3, 4, 5, 6, 7 up to infinity. So you understand this point, right? Because if we move from leg 3 and compare leg 1, so the difference between the legs is more than 3, then the correlation will be 0. That's the point in here. I want to give a specific example. Okay, do you have any question in here? Why don't you have a question? So let me write the. Do you have any question in here? Yes.
So, just going by the example, you opening a car garage and I have 4 cars. What if I want to predict what would happen on the first day? What model would I use? I don't have any previous sales. I want to predict how many sales.
The car sale example that I gave in here.
Yeah, on the first day. How can we predict how many car sales?
In first day, there is no prediction. This is coming, actual value is 4.
What if I want to predict that? So there's no prediction for that.
We can assume, but there is no mathematical model for that one, right? The way they formulated these things, this is why that is why I wrote a sentence, right? And then after writing the sentence, I have explained how the weights will be applied to the next steps. The weights are applied to the next steps in order to complete. So his question is how I just want to predict the first one. The way model is formulated, the way model is given. So first one you cannot, that one coming from actual, but the rest of the thing you can successively get like this.
What if you have historical data? Historical data.
Historical data you can use for that one. So that means the gentleman is saying that historically I can produce that way at the first day of the opening of the car dealership, I can maybe use 5 car and sell car, but 5 or 10 car. But historical data depends also on the many other factors. Why? Because if location is very busy in Chicago downtown area, a car dealer might sell 20 cars each day. And on the Macomb area, maybe they can sell just 1 car in a week.
Right. How can we use those factors to do marketing stuff like that?
Yeah, those could be included in here. Maybe you might ask me questions here. We are here. All the so that is why at the very beginning I say, I'm predicting only one series. I'm not considering any other covariate. Are you considering any other covariate? No, right? At the very beginning, I write a sentence in here, right? Why did I write the sentence? MA model predicts future values of a time series. That means a time series value you're predicting using the past errors. So these are the beginning point. We cannot include here other factors incorporating here. Okay. So the questions that I actually wanted from you, is there any way, so all the books that I have find that they have given some kind of values is in their psi. Why they don't estimate these things? Are you understanding? These questions I wanted to ask. When I read multiple books, multiple things, then all the things they mention the certain values of psi is given. Because remember, down the road, anytime in the future, if moving average model come, immediately think about this table. That is because they have make an actual value they started, and then they make a error with certain values of this. The error, how can I compute? By multiplying this with the original one, then I am adding these things and going. So second prediction is in the morning, I am predicting 4 from the previous day sale, but the actual was 10. Now previous one plus actual I am adding, then I am getting the new one. Okay. So if you ask a question like other factors by incorporating, can we update the model? At least not in the moving average model. But my questions that I wanted to answer, at least I was searching that, is there any way instead of someone giving some value -5 walking down the road, hollow, he said, Muhammad, it is -0.7. Is there any way we can estimate these things? Okay. So these values, if we want to use moving average, we can go to the historical data and how the sales are working. What are the factors they are using? From those cases, this is coming, this 5.5. You understand, right now? So that 0.5, any type of time series that I am fitting the model, I have to have some kind of history. So let's see how that time series work, in their time series model, what value of psi they are using. Those are the scenarios from where this is coming. Okay. So that was the question I wanted to ask. Like if you can ask me this question, like how the psi value 0.5 was determined. So that is coming from historical data for same type of series that they are using. From there, they consider that it should be -0.5 or -5, something like that. Okay, for the specific case, now I am going to give you, it is copy and paste from the book. Okay, for a specific case, where yt equal to et minus e t minus 1. Here there is a hidden 1, phi 1, and my plus 0.6 e t2. Okay, e t2, and then what is the value of 1? That one is -1 plus 1, -6, 1 plus 1 square, -0.6 square, which will give you -1.6 over 2.36 equal to -678. And row 2 equal to 0.6 over 236 equal to 254. Okay. Clear, right? So for a specific case, so now you will be super known to the people in the world. No, I don't want to use previous historical data to get the psi value. If you can develop a mathematical model to estimate these things, you will be famous too. Are you understanding? I was trying to actually how these things can be estimated. Okay. So general formula is this. So I have started with M moving average 1 and then moving average 2. Okay. So 1 means 1 lag of time, 2 lag of time, lag. Okay. So now general formula for moving average is what? Moving average of Q. General formula is what? This is the process T is theta 1, theta 2. Theta Q T minus Q. So what is the variance? variance is 1 plus theta 1 square, theta 2 square, theta q square. Sigma square. Where k is less equal to q, number of leg, and other one equal to 0 for k greater than q. Okay. So that is the general, this is the general variance and correlation coefficient formula we obtain for this. In the next class, I will discuss same thing again. What is autoregressive model? Okay, and then finally I will discuss ARMA model. Tonight I am going to add the homework and project. Okay, who did not come to my office? Someone of you want to have your like extra 5% points exam right now or not? You want to come next week? Next week. Monday 11 to 1. Monday 11 to 1. Monday 11 to 1. Tuesday. Okay. So Monday 11 to 1. Wednesday. Okay. Okay, Monday 11 to 1. So don't come all of them. So you can come at 11, okay? And then who else is coming? You come 11:15. You want to come at what time then?
12.
Yeah, 12 is fine. 11, 12, and who else? Monday is who else? Okay. Eric. Can you hear me, Eric?
Yes, Professor.
Okay. You have to take what is called like 5% is extra bonus point appointment with me. What time you want to have a appointment with me?
I'm not sure. I work from 8 to 5
Every day?
Monday through Friday.
Okay. How about then Monday at night, maybe around 9 p.m.?
Yeah, I could probably do that.
Okay. So the 10 conceptual questions that I gave, so I'm going to ask questions from there. Each question now carry 0.5%, 0.5. So that means 10 questions, there is a 5% point extra credit. That is not included. It is now your grade will be out of 100 or 5. If you get 90, then you will get A. So take preparation on that. So Monday at 9, okay?
Yes, that's fine.
Okay. Any other questions do you have?
Is it how many questions is it?
You remember conceptual quiz? There are 10 questions.
Will it be from those 10 or
Those
a different
10,
set of
yeah,
10?
but I will answer in a different format.
Okay. I don't know if I remember them. Okay, thanks.
Okay. Okay, then see you in next week with autoregressive moving average model, okay?
Thank you.